we have a given binary tree in which we have to return the sum of all the leaves. That you can see the statement here already is written, right? Give me one second. So we have given the root of binary tree, right? And we have to return the all the leaves sum, and like leaf is what is a leaf node? Leaf node is having no children, right? A node having no children is called leaf node, right? So we have to find all the left leaves and we have to do sum, and then we have to return, right? So in this case you can see what we have given. We have given in the example, this is 3 is the root node, then we have left children is 9. So we will calculate this 9 in the sum, and if you will come to the right side, we have another subtree 20, 15 and 7. So we'll calculate 15 here. So we'll add into the sum. So 9 plus 15 is become 24, right? So this you can see the explanation also, right? So we have given the root node we have given, and we have output 24, and it is saying there are 2 left leaves in the binary tree with the value 9 and 15. Means we have to do sum with 9 and 15 and we have to return. So this is Leetcode easy questions. So I'll suggest pause this video and do hands-on and try by yourself first, and if you are facing any problem, let's catch up in this video. Okay, so I'm going to pause for 2 minutes. Okay, come back. So if you have tried, it's fine. Otherwise, let's continue to see this video how we are going to do, right? So in this video we will see the recursive way, and then I will go with other approach, right? Means we will go with DFS and BFS, because in the tree traversal either you can do DFS or BFS, right? Means 2 approaches that we will see in this video. Okay, so the question is saying we have to find all the sum of leaves, right? Leaves means if you see this binary tree, right? So here if you see the leaf nodes are this and this, right? But how we are going to, if this is big tree, then how we are going to find this, right? So first of all, we'll create a we have given function, right? We will get this root node, right? So from the root node we'll check if the root node is not null, right? If it is not null, then we'll go to the you can say left subtree, right? In the left subtree we'll find all the leaf node, right? That is in the left side. Similarly, we'll go to the right one, right? And we'll find all the leaf nodes, and we'll do sum, and then we will calculate the final sum of this number of leaf nodes from the left side, and from the number of leaf nodes of left from the right side, right subtree, right? Then we'll calculate the sum of the leaf nodes, left leaves from the left and right subtrees, right? That we have already calculated, right? So what we will do, first of all, let's suppose, because I told you, so if the tree is not null, right? So if not null, then we have to create a recursive function. So in the recursive function we'll pass the root, right, and a signal, is this left or right? If this is left, we'll take it, right? If it is right, we will not take it, right? Like this. But we have to check all the leaf node, right? Means in this tree we will go, but we have to take this one. We will not take this one, right? But the function should recursive call this one, and will check further children's, right? Like this. So to do that, we have to pass what is this left or not, right? So we'll take a boolean value and we'll say is left, right? If this is left, means we will take it. If it is not left, we'll do traversing, we will go traversing, but we will not take it, right? Means if it is left node, we'll take it. If it is not left one, then we will not take it. Okay, we'll just do traversing, right? So how we are going to do, let's see in the program. I think you got it, right? What we have to do, we have to traverse all the leaf nodes, right? But we will take it only for the in the sum, we'll calculate only for the sum if it is left node, right? Okay, come to here. So what we have given here, we have given root is null, right? If root is null, then what we will do, we will make a condition, if condition, and we'll say if root is null, right? equal to will do null, like this, right? If root is null, what we will do? We will return, what we will do? We'll return 0, right? Then we will calculate the sum of left leaves from the left and right subtree, right? How we will calculate? We'll create a recursive function, right? Let's suppose I will give the name dfs method, and this is dfs recursive function, so I'll say dfs recursive and this is function. You can write like this, or you can only write dfs utility like that. Okay, so I'll create root, will pass this root, current root, and the is left or not. So initially I'll say this is the root node, so this is false, right? Now we have to create a recursive function, like this is private method. We will create a private method and it will return int, and we'll give the same name, dfs recursive function, right? Okay, now what we will do? We'll pass the tree node, is nothing but node, and then boolean is left, right? So this is your method signature, right? What we will do? We'll pass the tree node, root node, and then we'll pass is this left or not. If it is not, then we'll continue writing the code, right? So first of all, we'll check the current node is null or not, like that we have done already with the root, right? So if this node equal to null, if this node is equal to null, means we don't need to do anything, just return sum as a 0, because return type is integer, private int, right? Int, return type is integer, so we will return 0. Now we will check if the root node, if this node is left leaf node, right? Means we have to check the node is a leaf node and it is a left child, right? How we'll do that? So let's suppose we'll say the node dot left will do, the node dot left will do if equal to null, and node dot right equal to null if node dot left and node dot right equal to null. And we will make one more condition, and is left is true, right? Is left is true. If this is the case, then what we should do? We will return it, node dot val, means current node value we will return, and we'll say this is your value, right? But we have to do recursive call for the left and right subtree. We have to do recursive call for the left and right subtree. So we will find all the you can say left leaf node, and from the left subtree and from the right subtree, right? Recursively we'll find from the left and right subtree and we'll do sum and we'll return, right? Actually that is the case, right? So how we are going to do? So let's suppose we'll create two variable. Okay, so from the left sum, means this left sum will come from what? Left subtree, right? From the left subtree. How? If we'll write dfs recursive fun that we have already taken, and then we'll see node dot left. This is the node left subtree, right? And left subtree when we're passing, we'll say true, means is left is true, right? Similarly, if we'll talk about right one, I'll copy this one and I will put in the next line. Okay, so in this time the is left is false, right? Means we have to traverse, but we will not take that value, right? And this is nothing but right. If it is right, then the is left is true, false, and then this is here become right. Got it? Then this is a very simple thing. Then we have to return what? Left sum plus right sum, like this. Left sum and right sum. What I have done? I have first check if the root is null. If root is null, give me 1 second, okay? Okay, let's discuss here. Okay, so see what we have done. First of all, what we have given? We have given a root node, right? Let's suppose it was given 13 initially, then we have given 5, then we have 7, let's suppose, then we have given 20, then 9, like this we have given, let's suppose, right? So first of all what we have to do? We will check if this is null. If this is not null, then we'll continue finding in the left subtree and in the right subtree, right? Like this. Otherwise we'll return 0. Okay, so we have created a DFS method, and initially when we are passing this node, we'll say this is false, right? Because this is not is left, right? So we have created a function node and is left, right? So in this function, what we are doing, if we don't have any children, let's suppose if we don't have any children, means the current node, even the current node is null, will return it 0, right? But if we are saying this node is what? Node dot left is null, there is no data, and here is no data, right? But this is in the left one, means it is on some parent is there, right? Means there is a case when we have already crossed from 13 and we have came to 5, right? And this having no children, there is no children, right? Here is no children, here is no children. So this is left of this one, this node, right? So in that case we have to return this. So we have to return this. So we will return node dot value, right? Now because once this is left is true, is left, we are talking about if this is right we will not take, if this is left we will take it, right? So is left is there and both children left and right is null, so we will return node dot value, this 5 we will return, right? So what we are talking about, so for any node we have to take left, we have to traverse left and right subtree, and we have to find all these left one, like this one and this one, right? We have to find. So to find that, we will find left sum and right sum, right? We will do recursive function calls and then we'll do sum of the left and right subtree, right? If it is left and right subtree, we will get because of this line of code, right? If left and right is null, right, its children is null, then we'll get our left leaf node, right? So leaf node is having no children, so only for that we have to make these two conditions. We have to say node dot left null and node dot right is null, both should be null, and it should be is left. So this condition is making your program. Okay, this is the main you can say logic of your program. So always you have to see node dot left is null and node dot right is null, and this node should be is left, right? Then we return that node. Otherwise we have to traverse left node and right node with this condition. If it is left, will pass true. If it is not null, if it is not in the right subtree, we'll say false, right? and then finally we'll do sum of these two nodes and we'll return it. So if you talk about the time complexity, so we are recursively we are going with all the nodes, so level will be of n, if the level of binary tree is from 0 to n, so we will traverse all the nodes, so time complexity O of n, and we are not taking any extra space here, so we'll say a space complexity will O of 1. Okay, so okay, so I have observed that we have error at this line number 19 and 20. We have to write the correct name. Let me run this. Yeah, let's submit this. Okay, so now we have to write a different approach, right, rather than the recursive function call. So how we are going to optimize in different ways, right? Give me 1 second. Yeah, so a different approach we can apply, like we have seen the DFS recursive method approach, right, and then we can do other approach, right? So in this other approach, what we can do, we will not use the recursive function, but we can create a, you can say, queue, right, and we can traverse a BFS way, and we will put all the node onto the queue or a stack, right? So let's suppose we are going to take a queue. Okay, sorry, we'll take rather than a queue, let's suppose we'll take a array DQ, and we'll assume that this DQ is a stack, and then each element, first we will add a root node, then we'll add a left node, then we'll add a right node, right, like that we'll push, and then we'll check the same condition. If the node having left is null and node dot right is null, right, as well as this is left node, right, then we'll do sum, we'll put into the sum, otherwise we'll push left node and right node will push onto the stack. So we'll do recursive calls and we'll find the answer. So I will suggest you pause this video and do hands-on by yourself, so we'll have more understanding for you. Okay, so let's continue. I will suggest pause and try at least one time. Okay, so now what we will do, we will going to do with the BFS, right, approach, not the recursive calls but the BFS approach, right, or you can say not recursive or iterative way we can also say. Okay, so in this way how we are going to implement, so first of all we'll take a sum that we have to return, right, so I'm taking sum as a 0 value. Okay, so let's suppose when we are doing iterative approach, means we have to return the same value here, return sum here. Okay, in between that we have to make the approach. So I'll take a DQ, you can say, I'll take a DQ, and we'll say nothing but a tree node. Okay, I will take a tree node, and this is nothing but your stack. Okay, and I will put new array DQ, okay, like this. Now what we will do on this stack, we will do push, right? Now what we will push, the root node we will push. Okay, on the stack having now root node we have, right? Now we'll create a while loop and we'll traverse until the stack is empty, right? So we'll make a while loop and we'll say in the while loop, not the stack is empty, So is empty method will check in the stack like this. Okay, and the tree node we have here, right? This is the tree node we have. This is node equal to stack dot pop, like this, right? If tree node equal to stack dot pop, then we'll say if node dot left, right? If node not left, first we'll go with the left only. Okay, if node dot left, we'll check the left node first, and then because we are not doing recursive first, right? So we have to check if node dot left is not null, right? Is not null. In this case, what we should do? If node dot left is not null, right, means we have to check its left node, right? If left node is null and right node is null, means this is the left node and it is not null, but we have to check, is it a leaf node or not, right? Is it a leaf node or not? Is it a leaf node? So to leaf node, how we'll check? If node dot left is null, right? If it is null, similarly that we have talked about in the last last approach, recursive approach, node dot right, because this is not recursive, this is iterative approach, right? So we have to do like this. If it left and node both are left, the left node having left and right left is null, right? Means this is a leaf node, right? And in this case we have to update our sum plus equal to with the node left value, right? Because this node left is nothing but your leaf node, so its value. Got it? Then we'll go with the else condition. We'll say else. We'll go with the else condition and we'll say if it is not, then we will put this left node. If this is not leaf node, if it is not leaf node, yes, if it is not a leaf node, if it is not a leaf node, means the control will come here in the else condition. And to do that, what we should do? We have to traverse it again, right? So to traverse it again, further, what we have to do? We have to put into the stack. We will put into the stack dot push. We'll do a stack dot push and we'll put into the stack dot left. Got it? We'll do a stack dot push and then we'll put the node dot left, right? So this part is done. Okay, so if it is node dot left not null, then we'll check is it a leaf node or not. If it is not leaf node, we'll push into the stack. If it is leaf node, we'll put into the sum, right? Like that. Now think about if this is here in the if condition, right? If it is right node, we don't need to do anything because this is not recursive, this is iterative approach. So we have to think like that. What we have to do? We will just put into the stack, right? So we'll check node dot right not equal to null, right? If it is not equal to null, means this is a right node, and so we have to put into the stack dot push. We'll do, and we'll push this node dot right like this, right? And then we have to return the sum that we have already done, right? So what we have done, we have taken a stack we are putting the root node first, and we'll get this node with the pop, and then we'll check if this node is not left. Then if it is not left, then then we will put into a stack. If it is left, then we'll check is left leaf, right? If it is a leaf, we'll check the right condition, right? And then we'll put. So that's all, guys. So we are doing of n operations here, and for the time complexity and the space complexity is we are taking we are pushing all the node here in the stack. So we'll say of you can say n time is the space complexity. We are taking extra space, right, for the array decay. So let's determine the space complexity and time complexity of this program that we have, right? So to find the sum of all the leaf nodes in the binary tree, so the time complexity depends on the number of nodes the algorithm processes, right? So in this algorithm that we have used, so a stack dot push that we are putting all the nodes, right? So it will take of 1 times for each push, right? So while we are doing a stack dot is empty, so loop will run once for each node in the binary tree. So each node is pushed to the push it to the stack, and then we are popping from the stack exactly once, right? So inside the loop, if we are also checking if the node dot left is not null and node dot right is not null. So both operations taking off 1 times, and condition to check if node is leaf, right? So node dot left sorry, node dot left equal to null, and node dot left dot right equal to null. So so we are checking this leaf node, and the subsequent operation is also taking off 1 time. So stack dot push and stack dot push we are doing for the left and right node, so operation will take off 1 time. And since each node is processed constant time, so overall complexity is of 1 time that we have seen, and because n is the number of nodes in the binary tree, right? If we'll talk about the space complexity, so space complexity is determined by the maximum size of the stack at any point in the program, right? So in this worst case, right, for a completely unbalanced tree, skewed tree, you can say, the stack can hold all the nodes, and it will result in a space complexity of n times. So for a balanced tree, the stack will hold most of h times. H is the height of the tree, right? And for a very imbalanced tree, right, so the height will become O of log n times, right? So thus in the worst case, the unbalanced trees are having space complexity O of n times, but in the best case it will become O of log n, right? So to summarize this, we can say time complexity of n and the space complexity is O of n in the worst case, and in the best case O of log n times, right? So thank you guys, thank you for watching this video. If you really like this video, please hit subscribe, and if you have any thing to say, please put me in the comment box. Thank you guys, thank you for watching this video.